So here we go. Let's get our packets out. We got, oh my gosh, there's tons of stuff in there we might as well take advantage of. Let's turn to page 3 of your packet, page 3. Remember, I will be gone a couple days next week, so please make sure you have your headphones or whatever you guys call those things, so that you can be keeping up. Because what will be on the videos will not be retaught. I mean, that will be the lesson for today. So make sure that you are prepared. And I wanted to make sure you were left in good hands. So Mr. Mauger will be here to take care of you. And he has, a couple of months ago, he asked for a Precal A book. He's been studying. He wants to be right up with everything. So I need you to be on your best behavior and cooperate. I know you will with Mr. Mauger. Okay, so we're looking on page 3. We're getting ready to take a quiz over just the most basic logarithmic evaluation. So we look at a problem like A, and this makes no sense. The way it is written makes no sense even to me, and I'm the teacher. So I translate that immediately. It's just habit. I translate it, and it says 3 to the 1/3 equals x. So the answer to the question is either 3 to the 1/3. It's perfectly fine to leave it that way. If it's easier for you to think of it as the cube root of 3, that's fine too. Makes absolutely no difference which way you answer it. B is exactly the same thing. It doesn't make sense to me the way it's written. I need to know, what does that equal? That does not make sense to me. So my brain immediately translates it into what? 2 to the x equals 8. And then I know exactly what the answer is. The answer is 3. We talked about yesterday that an alternative way to do this problem, and again, no judgment, no better or worse, just another way. If you have the log base 2 of 8, you can think of that as the log base 2 of 2 cubed, because that's what 8 is. And we talked about yesterday, the log base 2 of 2 cubed is just going to be 3. So either way you do it, it makes no difference, whatever makes most sense to you. I'm going to pounce, Patty. Put it in the backpack. Okay, so next one. This, I don't know, this just looks hard. It doesn't make any sense to me the way it is. But then I remember something. What is ln? Natural log. It's a natural log, but what is it? Log base e. So this is really the log base e of e to the root 7. What happens to the log base e of e? Gone. So the answer is root 7. Same thing with d. Log base a to the 5th root of 8. Now, we don't like radicals in logarithmic expressions. So I'm going to rewrite that 5th root. Wow, what does it mean to be a 5th root? 5 to the, or excuse me, 8 to the 1/5. Well, now I'm right back to where I was a minute ago. The log base 8 of 8 to the 1/5 is 1/5. All right, E. I think it's a 6. We're uncomfortable with radicals in logarithm land. We also don't like this 1 over thing. So what do we do with 1 over? We rewrite it with a negative exponent. So this is ln e to the negative 6. Now again, looks so hard, but not if you remember what ln stands for. What does ln stand for? Log base e. So now we've got the log base e of e to the negative 6, so the answer is just negative 6. All right, what about f? 0. The log of 1, remember that was one of our properties yesterday? The log of 1 is always 0, no matter what the base is. So this happens to be base 9, it could be base 10, base 5, base e, doesn't make any difference, the log of 1 is 0. All right, G, little bit tricky. Do not be afraid. Simply cover up the 3 for a moment. Now, can you evaluate that? Yes. You can do it a couple of different ways. What's one way? You can set it equal to x, and then translate it and say 2 to the x equals 4, so x equals 2. So this equals 2. All right, so hang on to that. But let's look. What's the other way I could figure this out? This is 2 to the second, so the answer is 2. And you're going to do it whichever way you're most comfortable with, right? Doesn't make a bit of difference. So this part of the problem right here is 2. Everybody got that? All right, what am I going to do now then? 3 times 2, so the answer is 6. So I am not worried about that 3 sticking out there in front. Okay, now that's what our quiz is over, but let's go ahead and finish the sheet because we should know all the rest of this stuff too. So look at number 2. Patty, we're on page 3. Look at number 2.
I know.
Oh, good. Awesome.
One step ahead of you.
You are always one step ahead of me. Can you answer A?
Hey.
We're on number 2A.
Sorry. Resistance percent growth or decay. I'd say growth.
Why would you say growth?
I would say it because there's positive values.
Okay, all right. So there's some merit to that thought, Patty, but I need you to be careful for a minute. I need you to think about what you are doing. I need everybody to be thinking about this. When we take 18 times 0.14 to the t, what that means is you are taking 18 times 0.14. When you do that, Patty, when you multiply a number times 0.14, does it get bigger or smaller?
I know it gets smaller, but there's that t.
Well,
it could be that the decimal itself gets bigger.
No. Well, only if t is negative. Okay, and t isn't going to be negative because in these problems, we're generally talking about like populations. So like we're starting with 18 people or 18 bacteria or money, sometimes $18. So t is going to be a positive number, the number of years or the number of minutes. So we are multiplying by 0.14. Patty, what happens when we multiply by 0.14?
I guess you've corrected me. It's decay.
It's decay. It gets smaller. Now, who can tell me the next answer, which is, what is the rate of decay? We figured out it's decay. DeAndre?
86%.
86%. Beautiful. Somebody is going to say 14, and that's wrong. Remember, the rate of growth or decay is either 1 plus something or 1 minus something, right? So this number is 1 minus 0.86. So this is 0.86 or 86% decay. Whatever we have is shrinking really fast. 86% decay. What's the initial value? How many are we starting with? 18. Good. LOG is a symbol for? Well, common logarithms, which are log base 10. That's important because you're going to see a problem like this, kids, and if you don't understand what the base is, you're not going to be able to do that problem. The answer is 2 because the base is 10. So you got to know LOG is the symbol for base 10. Number 4 is this exponent thing. We've done these so many times. Oh, how would you start this, Maria?
Probably take it to the 1/2 power.
All right, so Maria says she's going to take the whole shebang to the 1/2 power. Remember, in a problem like this, there's no place you have to start. There's tons of stuff that has to be done. Just start doing it. So Maria says, I'm going to take everything to 1/2 power. That does include the 9 and the 16. So when I raise 9 to the 1/2 power, what does that mean? That means the square root. So 3 x to the 5/2, y to the -5th. Everybody keeping up? 16 to the 1/2 means 4, square root of 16. x to the second, y to the fourth. All right, Emily, what would you do next if you were doing this? She says I got a negative exponent here, so I have to take care of that. So I'm going to move that to the denominator. When I move it to the denominator, it's going to join, these 5 y's are going to join those 4. So I'm going to end up with y to the 9th down there. Is that okay with everybody?
Yeah.
All right, Francis, we're almost done. There's one more thing we need to take care of. Do you see what it is?
Yeah, the x's.
The x's have to be taken care of. And we've got 2.5 x's on the top and 2 x's on the bottom. So we can start canceling. And what will we be left with? Half x on top. The top has more than the bottom, so the leftovers are going to be on the top. So we're going to have x to the 1/2 and 4y to the 9. Anybody have a question about that?
Use the square root of x instead.
Yes, if you would prefer to write your answer with a square root, you absolutely can do that. Makes no difference whatsoever.
Can you move your negatives first before square?
You can do stuff in all orders. Yes, yes. Again, everything has to be done. So eventually we have to end up with this answer. But the order that we do things, completely individual choice.
Oh, I don't know if he asked this, but do you have to put that in square root?
No, the question was, can I? And the answer is yes. It doesn't have to be. You can if you want. Okay, now that last question is actually, we're not ready for that one yet, so we're going to hang on to that one and come back to it. So what we're going to do right now is take our little quiz. This is not going to take very long, so we're only going to take a couple minutes for this. And then we're going to move on. So, you want version A or B?
Yeah, that's how you
B?
do
You go switch
All right,
every
so
time.
let's spread ourselves out. No calculator.
Dang, I gotta move too.
No calculator. Keep your eyes on your own paper. Some of these are not even going to require showing work, so if you can do the problem without showing work, that's fine. But I do need you not looking around.
Was this
At all.
birthday in July? No, this one's
Can I sit back here?
So,
Yeah.
we got many more birthdays to come, dude.
All right, so yes, does anybody want to use a bonus question today? Yours is in July.
I was supposed to put x equals.
No, you don't need to put x equals.
Mine falls on Sunday, so
Okay, yeah. So when is your birthday on Sunday?
February 25th.
February 25th. When was yours? Okay, let's do it. Let her do her July one, and you can do yours, Patty. Another day. Anna, you do, honey.
Come on, baby.
How many sides are on a square?
How many sides does a square have? Up by your name with a circle around it. How many sides does a square have? When you're done, put it in place, please. So it should take a minute. Learning to do today. on page 317 when we are ready here. Okay, everybody getting done? Okay, if you're not finished, let's be wrapping it up. Today we're going to talk a little bit about some more properties of logarithms. Yesterday we had 2 properties of logarithms listed, or maybe 3 listed on the board. You may write those down. I had them up here in a box. Did anybody remember what we talked about? A couple of them. Properties of logarithms. We talked about. Yep. Was X. I may have used N yesterday. It doesn't make a single bit of difference. That's one of our properties. And in fact, you could have used that property on the quiz if you wanted to. Anybody remember another thing I had written down there?
I like the end of it.
I had the log of 1. We said the log of 1 was always 0. That's another kind of big property. I think I meant to write this one down. Did I write that one down? We talked about problems like that look like 8 to the log base 8 of 7, and the answer is 7. So that's another property. Those were really the 3 that we talked about yesterday. Now we also talked about that very fundamental relationship. I said it was the most important thing I was going to say all week, and I meant it. That it was really important. That notion where we take something like this and we can translate it into an exponent form. And what exponent form is this?
X equals b to the y.
B to the y equals x. Yes, that's exactly right. So that is not really a property, that's a translation, but you can include it in your property list. It is very, very, very important. It's what allows you to do the questions like on the quiz. Well, today we're going to add to our property list so that we can start solving more complicated logarithmic equations. Okay? So what we're going to do is, we're going to look at, on page, what did I say, 317?
Yeah.
At problem number 1, and we're going to try to figure out what in the heck they're asking us to do. It says ln 8x, everybody knows what that means, log base c. And it says, use properties of logarithms to write the expression as a sum or difference. Now, you learned this last year. Does anybody have any inkling of how I might I'm going to break this up. I'm going to split it up. Does anybody know how that might work? Can you remember that? Do you remember that?
Was it like ln 8 times?
You're very
Or
close.
8 ln.
No, you're very close. I'm going to break it up, and I'm going to have ln 8, and I'm going to have ln x. But I'm not going to multiply them. I'm going to add them. Very, very good. Remember, when you multiply numbers, you add their exponents. When you multiply numbers, you add their logarithms. So the property says that we're going to add to our property list. The property says that the log of AB is the log of A plus the log of B. When you take the logarithm of a product, it's the sum of the logarithms. Now, kids, that works both ways. So if I had the log of 10 plus the log of x, I could actually put that together and write it how? Log 10x. So again, the property says that when you take the logarithm of a product, it's the sum of the logs. Vice versa then, the sum of the logs is a logarithm of the product. Okay? Now, probably then, you don't have any problem with number 3 that says the log of 3 over x. How do you think that's going to be split up?
Log 3 minus log x.
Log 3 minus log x. So we're going to have a quotient in our problem, and the logarithm of a quotient is the difference of the logs. So the property says the log of a over b is the log of a minus the log of b. And it's going to work both ways again, because if we have the log of 15 minus the log of y, we can put that together. And in fact, when we solve logarithmic equations, we have to put that together. How would those be combined then? How could you rewrite those as one logarithm? Log of 15 over y. Very, very good. Now, there's one more property that we can talk about, number 5, log base 2 of y to the 5th. And I think, I can't remember for sure, but we may have actually talked about this one yesterday, or the day before sometime. We may have talked about this one sort of. When you take the logarithm of anything to a power, think about those equations we did, those word problems we did yesterday. When you take the logarithm of anything to a power, what are you allowed to do with that power? Put it out in front. So this could be written as 5 log base 2 of y. Right? So that's it. So when you run into something that says 2 log base 8 of x, you know you can rewrite that if you want to. You can rewrite that how? Log base 8 of x squared. The properties work both ways, kids. You can either pull the exponent off if you have a need to do that, or you can put the exponent back on if you have a need to do that. So that property, I'm making a list now. So we had the 3 from yesterday. We've added these 2. I'm going to add one more. The log of a to the b is b log a. So those are the biggies. Those are the ones that we're going to be using to solve all kinds of logarithmic equations. So you don't need to dig it out, but if you have it out, great. But remember that I said we couldn't do that last problem. Everybody have these written down that wants them written down? That last problem on that old quiz that we were doing for review, I said we weren't quite ready for it, but I think now we are. Look at this thing. This is scary. Look at that. You're supposed to solve that equation. That's a scary looking equation. Let me give you one more piece of information. Logarithmic equations are not solvable if they have more than one logarithm on each side. Okay? So if they have more than one logarithm on each side, we're in trouble. How many logarithms are on the left side of that equation? 2. So what does that mean I'm going to have to do? I cannot solve it if there's more than one logarithm on each side. So I'm going to have to put those 2 together. Okay? I'm going to have to put them together. Any thoughts on how they might go together? Check that out right there. Chloe? No. No. At some point, I'm hoping they're going to cancel out, but they're not going to cancel out right now. DeAndre.
Don't you have to divide?
Oh, wait a minute. Yes, good. Let's talk about that. DeAndre says, look, there's 2 logarithms are being subtracted. What property did we just talk about? If logarithms are subtracted, what has happened to the numbers? They've been... Okay, let's go back.
They divide.
You divide, yeah.
Everybody
So
says.
the property says the log of a over b is the log of a minus the log of b. And it works both ways? So when I have logarithms that are subtracted, it means the numbers have been divided. So I have the log base 4 of x over 2 plus x. These two get put together, thank you, into a division problem. The property says the logarithm of a quotient is the difference of the logs. The difference of the logs is the logarithm of a quotient. It goes both directions. Okay? Now what? What do you think?
DeAndre has an answer.
DeAndre's on fire today. What, DeAndre?
I was just gonna say you could do like x over 2 plus x squared equals x.
Okay, you are so close. You said that not quite right, but you're thinking in the right direction. Let's step over here for a minute. What is the problem? What if the problem had been this? That was on the quiz you just took. What would you do with that? If you had to figure that out, what would you do? You'd say 4 to the second equals x. So what are we going to say here? 4 to the second equals x over 2 plus x. Exactly. Nobody, not even me, thinks in logarithms. You've got to translate it into an exponent form. So 4 to the second is 2, or x over 2 plus x. So 16 equals x over 2 plus x. How do I solve that? Multiply by 2 plus x. So 32 plus 16x equals x. It's going to be a negative. So 32 equals negative 15x. Is that right? Don't let me make a mistake. And x equals 32 over negative 15. Now, this was a bonus question on that quiz. Do you remember that? I wonder why it was a bonus question. Well, because it's got a tricky piece to it. There's a trick. There's something bad going on here. I want you to think about your BFFs. This is your logarithmic curve, right? Tell me about the domain of the logarithmic curve. Always positive. So in other words, whatever I take the logarithm of, it has to be positive. Take a look at my problem, the original problem. Can I put negative 32/15 in for that x? No. Because what's the domain of the logarithmic function? What is x gotta be in a logarithmic function? Greater than 0. Get your calculators out. Try to take the log of a negative number and tell me what happens. Press log any negative number. Error. Error. You cannot take the log of a negative number. It's not in the domain. So, what have I got right here? We've run into this kind of thing before. This is called an extraneous root. We didn't make any mistakes. We worked it out. We did everything right. We used our properties. It was wonderful. And then we got an answer that simply doesn't work. Boo, yeah. That is trouble. Bad news. No solution. This one has no solution. All right, everybody okay with that? There's one more thing I want to add, and then we're going to try to do some review problems real quick. But there's one more kind of problem we need to look at before I do some more of these. I'm going to do some more of these. Okay, everybody ready? All right. You have your calculators out, right? Yep. Okay, so if I said, let's find the log of 28.3, everybody can do that. Right? If you have a calculator, you can find the log of 28.3. What if you don't have a calculator? Oh, you can find it, but you have to use one of the old tables that we used when I was a student back in school. So if you don't want to have to use a book to look things up and then do all the arithmetic by hand, let's bring our calculators to class. Log of 28.3 is?
1.45.
1.45, whatever. Okay. And if I said what's ln 81.6, everybody could do that. 4 point something? 4.4. Okay, everybody good? The issues happen when we have something like the log base 3 of 21. Now, what's the issue there?
Calculator doesn't do anything but base 10.
Yeah, your calculator does base 10 and base E. Your calculator does not do base 3. Now, sometimes I don't need a calculator. For example, on the quiz, we had the log base 3 of 9, or, problems like that. I don't need a calculator for that because I know that 9 is 3 squared, so the answer to this would be 2. It's only when this number isn't a power of that I'm going to have an issue, right? So we're going to need to do what we call a change of base. If I want the value of the log base 3 of 21 for some reason, I need to change that base either to a base 10 or a base E, because those are the bases my calculator will accommodate. So here's what I'm going to do. I'm going to translate it into 3 to the x equals 21. Now, no one's confused about that, right? We've done that before. Now, think of the word problems we did yesterday, where we had some situation where 500 equaled, 10 times 4 to the x, or something like that. We divided by 10, and then what did we do yesterday? When we had a problem that looked like that, what did we do? How did we get that exponent not to be an exponent anymore? We took the logarithm of both sides, right? And when we took the logarithm of both sides, the exponent came out in front. So guess what I'm going to do right here? I'm going to take the logarithm of both sides. And notice, the base I'm using is which one? 10. So am I going to be able to type this in on my calculator? Yes, because I have chosen now, I got rid of the base I couldn't use by writing it as an exponent. And now I'm taking a base that I can use, so that exponent will come out in front. And what will be the answer to the question? What will I ultimately type into my calculator? Log 21 divided by log 3. Now, I want to do one more, and then I want you to make an observation for me. So let's try another one. Let's suppose, we've got something like the log base 7 of 100. Cannot do base 7. You paid $100 and some bucks for this dumb calculator, and it won't even do base 7. So you're going to have to change it. So what do we do first? 7, we get rid of the base we don't want. We cannot handle base 7, so we get rid of base 7. Now what? Log both sides. Could I ln both sides if that's what I wanted to do? Absolutely. You can log or ln, makes no difference. No matter which one you do though, the next step is the cool one. What happens now? X comes out in front. And we divide. Now, I type that into my calculator, being very careful to close the parentheses there so I get the right answer. Should be 2 point something, hopefully. Now, I want you to look at the original problems here, and I want you to look at what we ultimately typed into our calculator. Look at the original problems. This was the original problem, and this is what I typed in. This was the original problem, and this is what I typed in. Do you notice anything? Well, for what it's worth, there is something called the change of base formula. You really don't have to go through all of these steps each time. When you have a problem like this, it's always going to be the log of this divided by the log of this. It's always going to be the log of this divided by the log of this. Now, I have lived 57 years, I'm a math teacher, and I don't use the change of base formula every time I go through these steps because it makes sense to me to do that. But it will work every time. If you want to memorize log this over log this, that will work every single time. So, if you want to memorize that and you have to do the log base 8 of 11, you know the answers are going to eventually come out to be the log of 11 divided by the log of 8. Now, type that in on your calculator, and then type this in on your calculator, because Anna just told me it wouldn't make a difference, and I want you to see it doesn't make a difference. So type this in, get whatever that is, then type this in, and tell me what happens. Same number. So you're going to pick LOG or LN because that's what your calculator requires you to do, but it does not matter which one of those two you choose. All right, everybody on target? All right, let's do one more logarithmic equation. Finish strong, and then we will be ready to head off into our weekend. All right, so here we go. Let's try this one. See what kind of luck we can have with this. Now I'm getting kind of crazy here. This is actually on page 331, number 35. It's just an example of a logarithmic equation, though. Okay, so we've only done one logarithmic equation. This is kind of a hard one to jump in and do, but I think we can do it. Can't ever have more than one logarithm on either side of the equation. So you got a couple of choices here. What do you think you might do? You could, oh what? Oh, move the half. Anna says, this is not good to have this out here, so I'm going to move it. Anna, where are you going to put it? She says a coefficient on a logarithm is really an exponent. It's the reverse of what you were doing right here. When you pulled this exponent off, she's saying, no, I want to put it back. Good thought. Now what? What do you think now? Make it a division problem. Make it a division problem. And why would she want to make it a division problem? Because the logarithms are being subtracted. And when the logarithms are being subtracted, it means the numbers have been divided. We don't get out of here till we get this figured out. So, Yes! She says, look, the base here is E. Logarithms do not compute in my brain, so I'm going to translate it. E to the 0th equals x plus 3 to the 1/2 over x. Very, very good, Christina. Okay.
That's just
Patty?
And we might as well change the e to a 1 since anything to the 0th power is automatically 1.
Exactly. So e to the 0th, like Patty said, is 1. So we're going to write it as 1 equals x plus 3 to the 1/2 over x.
And then it gets much easier from there.
What do you mean?
Multiply the x out.
Okay,
bring it on
so
over,
x
make it-
equals x plus 3 to the 1/2, like that, Patty? Is that what you're talking about?
Yeah.
Okay.
Then we get to the meat of the day.
Mm-hmm.
Figuring out that mess of a way.
Mm-hmm. What do you think? You hate radicals. Okay, stop. Did you hear what he said?
I'm sorry,
He
but
said, no.
I'm
I
sorry.
mean, yeah, I'm sorry you hate radicals, but I'm glad you said that because Patty recognizes, what is this?
Square root.
That's a square root. So it might actually be easier for us to figure out what to do next if we rewrite it as a radical. Because now, what do you think we need to do? We need to square both sides. We need to square both sides. Now, you could have squared both sides at this point, absolutely, but for most of us, the clue is when we see the radical sign. Now it's a quadratic equation. It's a quadratic equation.
Oh, man.
Oh, yes.
Oh,
And if the stars were aligned, that guy would factor, but he doesn't. So what do we have to do? Quadratic formula, and you guys are saved by the non-existent bell. So yes, so you would do the quadratic formula, and then wait, and then you would double check what? Make sure it's not an extraneous root. All right, so keep your eyes on school. I'm gonna post some stuff there, like homework dates and whatever, and you need to
wait.
put next to it.
I really want to hear that pull this in this class, because I'm not trying to go to A.
Right.
I was really like, okay, let's not solve this problem fast. And just started talking.
Mallory, look at this. Both of you.
It took me
It's like,
so long.
talk about you.